Okay. So today we are talking about something that I think is really useful. I mean, if you can do the chemistry and develop a little type of material that maybe it interacts with a protein or a virus or anything in a very complex system, like what's going on in the brain, can study the brain impulses. The point is this electrochemistry, with the math that we're going to learn today, you can actually monitor the concentration of any particular analyte in any system. And it doesn't really matter how complicated it is. So it's really useful. I mean, they're all over the place. Oxygen sensors, DNA sensors, enzyme sensors, they're all over the place. So it's pretty useful. So EMF, dependence of EMF on concentration. Enrique, what the heck is EMF? Volts, exactly. That's what the voltmeter reads. Remember, they had all these different words for the exact same thing. They call it cell voltage. They call it EMF, electromotive force. They called it what? E-cell, right? And I think there's some other ones. It's just that what's the difference between E-cell and E0 cell? Standard. Which one's standard? E0 cell. So E0 cell you always get from the tables, right? So, okay. So when an electrochemical cell is at equilibrium, let's back up a little bit. Andrea, I've got a bunch of batteries here, pretend, right? And they are all at equilibrium. I just, put a lot of energy and effort to make sure that they are all at perfect equilibrium. Would you want them?
No, but kill them right. A little overshot?
Oh, yeah. But at equilibrium means what for a battery? It's dead, right? You want it overshot. You want that to be all reactants. And that battery, that alkaline battery, you want it to be 100% reactants, hardly any product at all. You do not want that at equilibrium because it's going to be dead. On a voltmeter, it's going to read how many volts? 0 volts because it's dead, right? It's at equilibrium. We know equilibria are dynamic. They go backwards and forwards, right? But the point is that it's at equilibrium. So when an electrochemical cell, a battery, any electrochemical system, when it's at equilibrium and under standard conditions, the below equation is used, okay? Because E cell is 0 volts. So pretty much all we're just using this Nernst equation, but the point is the E cell is 0, so you get 0.0592 over n log of k. And that's what we've been using. In fact, I think this is what the quiz was just on, to get k, okay? We could have made it more complicated and say that the voltmeter read 0, but okay. When an electrochemical cell is not at equilibrium, so this is more like that little electrode that's in the bird's brain, or right? Things are not at equilibrium. They're not under standard conditions. It's a bird brain. It's a cell. The below equation is used to get the potential of the cell. So E cell is what you read on the little voltmeter, right? The little wires coming out of the birdie's brain, okay? What's the rest of the stuff? E0 cell you get from the table. What about N? The electrons that cancel, right? When you add those two half reactions, right? Some electrons are going to cancel. That's what your N was, right? You're all with me so far? Okay, what is the Q, Andromeda? What's the Q? In fact, we had a fancy name for this. Right? They removed the K and they put in a Q. Does anyone remember what it was called? Reaction quotient. I don't know if that helps you or not. But the point was we had, they threw all the stuff in a beaker and they said, hey, is that equilibrium or not? All you did is you calculated a reaction quotient. And if it equaled K, then it's at equilibrium. If it was smaller than K, you needed more product. If it was bigger than K, you had too much product, so it shifts the other way. That was the story. So the point is the little birdie brain is not at equilibrium. So you hook up the little wires to the voltmeter, you measure E cell. Fantastic. Well, over here in Q is products over reactants. So the trick to it is just to know everything but one, right? Maybe you're after that enzyme concentration. Well, you have to know the concentrations of everything else that you can mathematically solve for what you're interested in. That's the power of the Nernst equation. So what we're going to practice first is the math, right? Like look down here. This is what I'm talking about, like for the birdie brain, right? The 0.25 volts they read on the little brain, and they're after the chloride in it, in the cell or wherever, and you'd be solving for it. So let's start with this one first. Okay. So we're really not worried about the concept. You read the math problem and you just typed everything into the Nernst equation, you end up with this expression, and they're after E cell. Okay. But no worries. Connor's going to tell us how to get a number for this. What would you do first? Now remember, Smith likes it, and I think your life is so much easier if you do it all in your calculator in one big step. That's really what I'm thinking. Does anyone see what to do first? If you're going to do it all in one big step in the calculator. You got to take care of what first? The log. You got to take care of that log first. So what I would do is I would put in 0.01, the cube button, cube it, divide it by 0.25, squared, hit equals, then push the log button, and then take it times 0.0592, divide by 6, hit equals, probably push the plus minus button to make it negative, right? And then add 0.35. Or you can write a couple numbers, but just try to write down the minimum numbers you need to get an answer on this. So try it. If you have to write something down, fine, but try to write down the minimum that you need to. If you don't have a calculator, I've got a bunch. Did anybody get 0.397?
I did.
Did you get 0.397?
No, it's because I forgot to
For the whole thing, the whole answer. If you can't get it all in one big step, then do it in parts, fine. If you can get it, help out the folks around you, make sure they can get this. So what I did is I put 0.01 cubed, right? I did 0.01, push the x cubed button, shift x cubed, divided by 0.25, has to be squared, so push x squared, hit equals. So I have 1.6 times 10 negative 5, I'm going to take the log of it. So push log, okay? Then I'm going to take it times the negative 0.0592. So times 0.0592, make it negative, push the plus minus button. Divide it by 6, hit equals. Now I've got 0.047, add it to 0.35. 0.397. Did you get it, Kenneth? 0.397. Did you get it, Enrique?
Nope, not at all.
Not at all? All right. All right, now watch. Follow along with me then. If you're not getting this, follow along with me. Right? Okay. And trust that calculator. If you have 6, this is one thing that I'm used to, and maybe you're not. If I have 6 times 7 plus 12, your calculator is smart enough to do the multiplication division before addition and subtraction. You just type it all in straight. Okay? But anyway, so do 0.01. Everyone have 0.01?
Yep.
Push shift x cubed. Right? What does your calculator say now? 1 times 10 to the negative 6. All right. Divide it by 0.25 and push x squared. Then hit equals. So right now I have 1.6 times 10 to the negative 5. Right, that's inside the log. So push log. Okay. Now I've got negative 4.795. So that's the log. Now I got to take it times a negative 0.0592. So times 0.0592 and push the plus minus button. That way I don't forget. All right? Then divide by 6, hit equals. I have 0.0473. Now I'm ready to add it to 0.35 plus 0.35, 0.397. Okay?
So since you're doing the point 0.592 is a negative, that's why you're adding the 0.5?
Well, I'm following that equation. That equation says negative 0.0592 divided by 6 times the log guy. So I have the log number, so I'm going to take it times 0.0592 and push the minus button. That way I won't screw up and forget about that stupid minus sign. And then divide by 6, then add the 0.35.
You done good.
Sorry, I got to about here, and then my calculator. So
Keep trying. You'll get it. All right, if you got 0.397, try the next one. Ooh, good question, Steph. You don't want to lose a point? Volts, big V. All right? Should be a V. So if you got 0.397, try the next one. See if you can figure out a game plan for this one. If you didn't get 0.397, make sure I can help you out. Did you get it?
Yeah.
All right.
Sure. Was there class on Friday?
Mm-hmm.
Because I heard you say there was no class, so I didn't come. Apparently there was. So I'm like, what?
On Battle of the Flowers. This week.
What was this week?
This week's Battle of the Flowers.
So like, I didn't come. So like, I was like, in the class, I was like, what's this? Like, I never seen this.
Oh, you'll survive, Jose. So now you should. Then you missed,
Yeah, I saw that. I was like, what's this? Like, I never seen this.
and you missed the quiz on Friday too. What are you gonna do to get this thing? Oh, I'd do that first. Like that's gonna go over there, and then the 2 would go up on the top. That one goes on the bottom, and then raise both sides to the 10. Raise both sides to the 10.
okay.
All right, you guys have a game plan for finding chloride? Yes. What's your game plan? Do what first? Move this over, right? Because what's the very last step? The goal of this is to get a number equals log, right? That's the goal, to get a number equals log. So then we can raise both sides to the 10 power, and then we're going to have to move the chloride up on top, right? And whatever we get, move it down here where this thing is, and take the square root. Okay, so that's the big picture. That's the big picture. Let's start it now. So the first thing is to do what? Move this over. Okay, so then you get a number equals this mess. Then what do you do? Move the 2 up to the top. Move the negative 0.0592 to the bottom, right? And then you're ready to raise both sides to the 10 power. So one step at a time. So first, Alyssa, get rid of this, right? Then you're going to have a number equals this mess. So move the 2 up to the top, the 0.059 to the bottom. Remember that game?
Yeah, I don't remember how that works. Just like multiply by 2. Right?
Well, just do. This is where if you haven't done a bunch of these, you should really write out the steps, unless you've done a lot of them. So I verbally say it so everyone has a game plan. So give it a shot. So I'll write out all the individual steps because this is an area where you could really screw up. This is just a,
Hold on, and then at the end you have to take the square root, right?
yeah. Okay, so you had to subtract 1.23 from both sides. Right? Mm-hmm.
Okay, can you break that stuff up?
All right, I'm just ready. Maybe I can get it darker. Here's a darker.
Break up the log part.
All right. Any disagreements so far? Seeing where I'm getting all this stuff? All right, but you get this far? Huh? So you didn't get this one? Okay, so this one you have to take negative 0.98 times 2 and then divide it by 0.0592, right? Remember, you're moving this guy to the bottom, moving that one to the top.
Wait, no, that's what I got. So yeah, because once you move this, the log is being multiplied by it. That's when you divide it over, which is being multiplied. Should is being multiplied by.
All right. Good question. Oh, yep. So remember how to handle these guys, right? The chloride squared has to go to the top. The 1.282 times 10 to the 33rd goes to the bottom, right? And don't forget to take the square root at the end. Would you want to move 0.02?
No, I'm just asking. Moving this one.
You got to move the chloride. And did I lose anybody in these steps?
What are we moving on the side where there's a chlorine?
What step?
Number 2?
Step 2? Did you get step 2 or not?
Well, I have it down, but I don't know what it's supposed to be. To get to 3.
Well, you have to get rid of the log. So you have to raise both sides to the power of 10. Because 10 and log are inverse functions.
So I did this one, I'm supposed to do the 10.
Yeah, but it's orange. You got to push shift first. Yes? Which step did I lose you?
We got up to the 1.282.
So you got here? Okay. So then chloride squared has to go to the, you just switch those two. Right? Just switch those two. Chloride squares goes to the top, that 10 to the 33rd goes to the bottom.
Is there supposed to be a
Good question. Bowdy answered it though, if you've heard her. Concentration is always in big M, molarity. Now, once you get this, go on to the next one. It's the same thing. It's doing this big, heavy math. But let me help you out if you're not getting either of these. Go on to the next one if you got both of them.
This Q, like before we get Q, which one goes on top? Which one goes on top?
Find the EMF of the following cell. So for that, what equation would you use? If you're getting started on this, what variable are they asking you to solve for? EMF, which is which symbol? E cell. They want you to find E cell, right? That's to me where it kind of starts. Okay, so which equation would you use out of all these? All right. Look at this. This second to last one looks nice, but does it have E cell in it? No. Right? You know that you have to do E cell. There's another hint. E cell. Are these standard conditions? Standard conditions is always what concentration? 1. So that's another little hint, right? That you're not at standard conditions. That's the whole idea of the Nernst cell. That's the whole idea of the little electrodes in the birdie brain. It's the Nernst cell, the Nernst equation. E cell is E0 cell minus 0.0592 over n log of Q. Okay, so what you need to do is you need to figure out what the two half reactions are, right? So you can figure out what E0 cell will be. So you can figure out what n will be. So you can figure out what the Q expression is. And remember, Q is just what over what? Products over reactants in terms of concentrations.
Do we only have to use the ones that they give us?
And you hope so.
So wouldn't it just
Okay, if there's anything missing, you're screwed. So odds are they gave you everything you need.
Yeah, but for the solids.
Do solids show up in equilibrium constant expressions?
Yeah, so but wouldn't it just be for like the Q and be 0.01 over 0.8?
Well, you might want to be careful. Maybe there's a 2 in front of something or other, right?
And if there's a 2,
So I would write an overall cell reaction. Otherwise, right? So it's dangerous just writing. See, Baudius had a good idea. Why not just have the, because you know products over reactants or something. But I would write the overall cell reaction, because what if there's a 2? What if there's a stoichiometric coefficient of 2 or something to get these electrons to cancel out? So I would figure out what the two half reactions are. The overall cell reaction. And you know you're going to have to use this one. So first, do this. Second, then substitute. First, figure out what the half reactions are. And you know just by you can look in the table, but you know it's going to be Pb solid going to Pb plus 2. Right, and 2 electrons. But if you're not sure, you just look them up and find them in the table. You need to find them in the table anyway to write down what those E0s are. So you might as well look them up.
so when we're in the half reactions, it doesn't pretty much ignore the 0.01 molar.
We're going to need it when we substitute into this expression.
So we're right in the half reaction.
Yeah, you don't care about concentrations. That's right. Let's just get an overall cell reaction so we can write our Q expression. Anybody look these up? Did anybody find the lead going to lead plus 2 E0? What is it? What's the number? 0.13? Oh, negative? You have to, whatever's in the table, you have to flip it. So what's in the table? Negative 0.13, so you have to flip it and make it positive. Right? So find the lead half reaction, but notice it's flipped, so whatever's in the table, you got to flip it. That's where she got the positive 0.13. And then the copper plus going to copper. Now this isn't quite balanced. What I need to do to make it balanced. You can either look in the table or figure it out. Add an E on over here. Good. Bless you. And what's the cell voltage? It's not on there?
Because it has a CU plus 2, but no CU.
And it's here. Cu plus plus an electron goes to copper, 0.52 volts. So that stuff has to be in your tables. I mean, if it's on a quiz or an exam, it has to be given. Okay, that's 0.52. And I wrote it down exactly as is, because this is reduction, right? So I don't do any flipping. It's exactly as in the table. Okay. Oh, and someone said I have to multiply through by 2. So do I multiply the E0 by 2? No, don't do that. Good. Let's write it on this side. Okay. So my overall reaction here is lead and 2 copper 1 ions goes to lead ion and 2 copper solids. And what is that? 0.65. Okay. So now we have everything we really need to substitute into our Nernst equation. You know what N is going to be? You can write an expression for Q, products over reactants. So it looks like you're going to have to square what? The copper 1. It's going to be concentration of Cu plus squared in the denominator. Make sure you don't forget to do that. And remember, solids don't show up, so that's kind of nice.
0.01 over 0.8 squared.
See, it looks just like the math that we were working on before. So you pretty much have to get that overall cell reaction, otherwise it's pretty hard to do. It looks like it's extra work, but it really isn't. So what I would do is I would take this, divide by 0.8, what is that, 0.8 squared,
How'd you get the square?
products over reactants. Because here's your reaction, so right, and solids don't show up, so concentration of this divided by the concentration of this.
Oh, that's from up here. Okay,
Yeah.
okay.
Didn't you have to multiply through by 2? So you didn't have a 2 in front of that. You didn't have a 2 over here. Right, because that 2, this one you had to multiply through by 2.
Where did you get this from? I didn't see 0.52.
Yeah, it's not in here. I think maybe you have to find a bigger table. Maybe this one.
Oh, okay.
There's this one. Yeah, other people couldn't find it either, so I had to. It's on the table that we have exams. You know. Yeah, you have to be given these half reactions. So did you get around 0.703? Great. Volts. Okay. And yeah, sorry about that. This half reaction was not in our tables. I don't know why. I got to fix that. But that stuff should be given. Okay. So one more. Oh, we've done this. Let's skip EX2. Let's do one where you find the concentration. Do this one. Let's jump down to EX3, and then we'll call it a day. So here, this is the only other type. Now you're going to set up that Nernst equation, and you're going to have to solve for the silver ion concentration. So you're going to get a nice mathematical equation, and the only unknown is the silver ion. So in this big mess of equations, which one are we going to be using to get our silver ion concentration? The same one, that bottom one, Nernst equation. And there's some hints. One is that 0.01 molar, so you know it's not standard conditions. Okay, so we're going to be using this one. We're going to use that, and we're going to solve for our silver ion concentration. This 1 volt is which math symbol? E cell. Good. That's my E cell. So figure out, it's the same game plan. If we're going to solve for silver ion, that means we need a Q expression. That means we need to know what the products and the reactants are. So that means you have to know the cell reaction.
Yeah, we have to solve for E cell, right, with the table.
Yeah, E0 cell will come from the table. And the E cell is the 1 volt because they told us that on the voltmeter. So you definitely need to figure out what that overall reaction is. And if you're not sure about the electrons, you can always just copy it right out of the table. But Whoa, what happened there? Ten plus 2. See, here's my final expression. And I just have to end up solving for the silver ion. So I know that my cell voltage, E cell, is 1 volt, so I just put that in. Figured out what E0 cell is by adding up the 2 half reactions. Figured out that N was 2, because when I add up those 2 half reactions, the little 2 cancels. There's 2 electrons. And then, remember that Q is just like an equilibrium constant. It's just products over reactants. And you always leave out solids and liquids. So it'll be the concentration of tin, which we know is 0.01, divided by the concentration of silver ion, silver 1, squared. And then we'll solve for silver ion. Let's get an answer quick, and then we can call it a day here. So did you get, I heard 1.03? That's what I got, about 1.03. .032. So give it a shot. Come by and I'll be glad to help you out with these problems.